Welcome to GitMap. In this session, we will work on fraud detection problem. As you might already know, fraud detection is an imbalanced problem because most of the transactions are non-fraud, and identifying those fraud transactions is a difficult problem. We will either explain those methods in order to overcome this problem, or we will implement them. Stay with us. Let's go ahead and get it started with fraud detection project. Hello. Okay, here is the different notebooks about fraud detection. One is exploratory data analysis, the other one modeling, which we go through the different classifier and ensemble learners, and finally the neural network, which this is gonna be our first GitMap video that we will be using the deep neural network in order to solve the problem. Let's start by exploratory data analysis. Here is some explanation about the data set. It contains 2 days credit card transactions made in September 2013 by European cardholders. No fraud accounts for 99% of the data, and frauds accounts for only 0.17% of the data. And the features are extracted PCAs from original data set. So these are not the actual features because of the privacy problems. And all of the columns are continuous variables. It is a large data set with more than 200,000 rows, and it doesn't have any missing values, which is a good news because we don't need to deal with the missing values. As always, we start by importing the libraries, reading the data set. You can see how the data set looks like. Here is the visualization of the target values. And this one shows the correlation heat map among PCAs. And finally, some analysis on the time and amount. So time and amount are the only variables that are raw and they are not principal components. Doing some analysis on them can bring up some information, and here are more analysis about their distribution. And finally, we tried to normalize the time and amount in order to prepare them for the modeling. If you need more information about each step, please check out the notebooks. These should be available on the GitHub, and we will provide the link for the GitHub repository. You can just go and read about them. Okay, let's do the modeling. For modeling, again here, we import the libraries, read the data, transform some of the variables, and finally, we do the splitting data into train and test. One important suggestion is that make sure to split data into train and test before moving forward, doing some sampling, and using the techniques for imbalanced data set. This is pretty important step, which I see is not done on Kaggle or GitHub in most of the notebooks. Before heading to the algorithms, let's explain about different type of the techniques to overcome the imbalanced data set. We have different methods such as oversampling, including the adaptive synthetic oversampling technique and a smooth algorithm. These are two important algorithms for oversampling. Also, randomly oversampling technique is another one. Main concern about oversampling is that it can cause overfitting because you add repetitive samples to the minority class in order to increase the amount, and that could cause overfitting. However, Smooth solves this problem by considering 2 instances in the fraud transaction dataset and creating new instance in distance between these two instances. That way this new sample will not be exactly the same as two samples, but still it's going to be similar. So still there could be some concerns about oversampling, but as of now, a smooth works better compared to the other oversampling technique. And then we have undersampling technique, which basically the algorithm tries to remove instances from non-fraud transaction in order to make it smaller and make it equivalent to the fraud transaction dataset. But the concern about undersampling is that when you remove data from non-fraud transactions, you lose the information about the dataset, which might cause some variation in the result. And the last one is algorithm-based, dealing with the imbalanced class. You let the algorithm to take care of the imbalanced class. That could be the algorithm by itself or adding the class weight to the algorithms. For example, here, in case of the logistic regression, we added the weights for the positive class. For the fraud transaction, we add 99, and for non-fraud transaction, we add 1. What it means is that if the algorithm misclassifies the fraud transactions, it gets penalized 99 times more than when it misclassifies the non-fraud transactions. That causes the algorithm to be more sensitive about frauds compared to the non-frauds. Hopefully this explanation could be good enough. Also, there is another way. As I have commented here, you can add class weight as a balance because scikit-learn library will take care of that and considers that in the algorithm and try to take care of the imbalance class. Also, the other algorithms we have tried, and here are the results. Let's circle back to the main part, which is ensemble learners. In terms of the imbalanced class, ensemble learners is highly recommended compared to the weak learners. And here we have applied random forest and extra gradient boosting, and you would see that extra gradient boosting works better compared to the weak classifier. And here is confusion matrix. Also, we have provided the feature importance, so you can compare different components and see which one works better. Also, we have applied downsampling on the training set, and after that we use the model that is trained using downsampled dataset in order to predict the class on the test set. You could see that the algorithm did not work well. So as I said, the main concern about downsampling is that you are losing the information that might be useful for the algorithm. The last but not least is neural network. So here again, we started by importing the library, reading the data set, and preparing them for deep learning model. The first step is we used a smooth, as I said, since it is popular, in order to subsample the data set and prepare it for the model. Why we do a smooth on the training set? Because if we don't do that, the algorithm by itself is going to identify all of the non-fraud transactions, and then the fraud transactions going to be considered as an outlier by algorithm. In order to make sure the algorithm can also identify those as a new class, we need to make sure subsample the data and have enough data instances from each classes. Okay, here are subsampled data. Here is the model. We prepared sequential dense model of neural network. Here are some explanation about each layers, nodes on each layers. And finally, we try to optimize the accuracy. And here is area under curve score. You can see that it is about 60%. And here is the confusion matrix. So for imbalanced class, the confusion matrix is really important because depending on what is your domain, you might want to optimize different metrics, different numbers. So for example, if you are working in the healthcare, you try to reduce the number of the false negatives. If you are working in movie recommendation, you might try to optimize the false positives. So based on your domain, you might need to optimize different values here. True positives, true negatives, false positives, false negatives. But specifically in this project, we use the F-score in order to make sure we consider the balance between precision and recall, so we can optimize both together. The other method that we have applied is semi-supervised learning. It is autoencoder-decoder. Basically, we will use the algorithm in order to create the training data, and we utilize the error in this direction in order to make prediction on the test set. So let's go through the algorithm and how we prepared it for modeling. Again, as always, we have the data set. We split it into train and test. We removed one outlier that we got from the exploratory data analysis. And we prepared data for deep learning. So here is the autoencoder-decoder. We have the encoder, we have the input and then the encoders and then the decoders. And specifically here, we try to basically encode the X train and decode it to the, again, X train and test it on the X test. And after that, we will get basically the error that we are seeing in the X test in order to make the prediction on the class on the X test. And you can see that here we consider the mean squared error between the actual X test and the predicted X variables. And based on the threshold, we can consider the value for the Y, the target variable. Here is the true class, here is the reconstruction error, and here are some analyses. You could see that we defined the predictive value based on some threshold about the error. And finally, here is the confusion matrix. You can see that the F1 score is pretty low, but if you are in industry, based on your domain, you can utilize this in order to reduce the false negatives or reduce the false positives. That's why really it is really important in the case of the imbalance class to understand the confusion matrix and see what would be useful for you in your domain in order to select the model, the best model, and make the prediction using that. Okay, so this one was quite comprehensive explanation about fraud detection, and there are a lot of the codes similar to this on the Kaggle, on the GitHub. We tried to clean them up and prepare the best one here for you, and also start introducing the deep neural network, talking more about that, and hopefully this would be a good project for you to try it out and
practice more.